Okay, so in the last video, we were able to go from particles to moles and moles back to particles. But we also can go from grams all the way to particles or particles all the way to grams. So this is a really key concept because what it does is we're able to take something that we're able to measure here in the lab, so mass in grams, and we can go straight over to figure out how many particles are involved in that amount, right? So if we have like a sample in grams, we can then go to that molecular level and figure out how many individual particles there are, right? Remember, particles are atoms. They can be molecules or they can be formula units, okay? And molecules and formula units look very similar in that they are talking about compounds, right? But we use the molecules to describe your covalent ones and formula units for the ionic ones. Okay, so in order to do this travel all the way from mass to particles, you're going to have to travel through the mole, meaning you're going to have to convert 2 moles, right? So the relationship between mass and moles, as we've seen, is your molar mass. And then we're going to have to go from moles all the way to particles using Avogadro's number. You can also go back the other direction by using Avogadro's number to get to the mole, and then using your molar mass to go to mass. Okay, but usually we see it in this direction. Okay, and so what you're going to see, so you got 2 options. You can take it in 2 individual steps. And so if that's going to be what you want to do, you're more than welcome to do that whenever. I recommend you go back to the tutorial video and the assignment that dealt with this, and you relearn how to go from mass to moles. And then you're going to go back to the video before this one, which was taking you from moles to particles, and relook at how to set that up. And you can do it in 2 steps. But in this video, I'm going to show you how to set it up in the T-chart the long way. Okay, so what we're going to do is I'm going to go ahead and just come up with a random number. So let's just say I have 14.67 grams of water. 14.67 grams of water. And I want to know how many molecules are in that. Okay, to question mark molecules or particles. Okay, we're not going to go to atoms because that's going to be an extra little step. You'll learn about that in the next few videos. But for now, we're going to go to molecules. How many molecules are involved in 14.67 grams of water? So just like before, we're going to start just like we were with what is given to us in the problem. So we're still going to start with what we're given. So I went ahead and wrote that down. We're going to open up our little T-chart here. We're not going to be writing in this box down here. We're going to start off by taking those words and we're going to bring them down to the right, right? So we have grams of water. Okay, we know we have to get to the mole, all right? And so we can't just put particles right here, okay? Because you have to, eventually you'll see that there is a shortcut that you're going to be able to do that. But for now, I need you to grasp that there is an extra step in here. Okay, so we're not going to just go straight to particles. Grams are not related to particles. Grams are related to moles. So what you're going to do is you're going to put moles in this top box. So moles of water. Okay, we're going to make a new box. We're going to bring words down to the right. So now we have moles of water down here. And now we can relate moles to particles. Okay, so look here, looking at this little image that I have up here, there is not a direct route to particles. You have to travel through the mole. You have to convert to the mole. Mole is like the universal language between everything in chemistry. And so you have to convert to the mole in order to relate things in chemistry, and then you can convert it to whatever else you're needing. It's going to be a key idea when we get to stoichiometry as well. Okay? So make sure you are always traveling to the mole. All right. So now that we have mole, we can now end with our molecules up here of water. And we know that we're going to do that using Avogadro's number. Okay, so now we can go ahead and fill in these numbers. Okay, so to start us off, I know that this relationship right here, this is going to be molar mass, right? So we got to think about this. All right. The molar mass of water is going to be 2 hydrogens, so a hydrogen plus an oxygen. So when I go to my periodic table right here, okay, I know that H is 1.008 and oxygen is 15.999. Okay, so I have 1.008. I'm going to multiply that by 2, and I'm going to add it to 15.999. When I calculate this, so I type this into my calculator, I can do it all in one step if I'd like. I'm going to go open parentheses, 1.008 times 2, close parentheses, and I'm going to add it to oxygen, which is 15.999, which equals I have 18.015 as my molar mass for water. Okay, so now what we can do is we know that it's this many grams per 1 mole. So looking at this definition of what a molar mass is, we can now put these numbers where they belong. So we're going to go ahead and put the 18.05 down here next to the gram, so 18.015, and I'm going to put 1 mole up here on top. I'm going to, like we did earlier, we brought the words down to the right, okay? Remember, the whole objective is that we're going to cancel these units out, right? So here we're canceling out the units again, but we got to now relate moles to molecules. That's Avogadro's number. So remember, Avogadro's number is 6.02 times 10 to the 23rd particles per 1 mole, right? So particles per 1 mole. All right, so what we're going to do with that information is that tells you exactly what we're putting into this table right here, right? So we have 1 mole. 1 is going to go down here on the bottom, and then we're going to end with 6.02 times 10 to the 23rd here on the top. Don't forget how you're typing this in. We're using an EXP button on the calculator, okay? All right, so to show you how to type this one in, I'll pull up my little calculator right here. We're going to end up with, we need to multiply everybody across the top. So I have 14.67 times 1 times Avogadro's number. So we're going to go ahead and go 14.67 times 1 times Avogadro's number, which is 6.02. We're going to hit exponent 23. I'm going to push equals. All right, so I now have this. This is my number that is totaling the whole top, right? So all of these things were being multiplied across the top. Now I need to do the step where I would be dividing. So a good habit to start getting into using Google Calculator is that you're going to be dividing by each one of these things on the bottom. So I'm literally going to push divided by 18.015, and I'm going to push divide again 1. Okay, so this is a good habit, like I said, to get into. Push divide every single time that you see this line, right? So divide, and if you had more along the bottom, you would push divide every single time. And what that's going to allow you to do is it's going to continue to divide the bottom numbers, which are all technically being multiplied, okay? And so it's just a good habit to kind of get into before we get to stoichiometry in a couple weeks. All right, so now I'm going to push equals. There's my answer. So my final answer for this problem right here, let me go ahead and change my color over here. All right, so we see 4.902. Let me look at my significant figures. I started with 4, so that means that my final answer should only have 4. All right, so 4.902 will be the 4 digits that I need significant figure-wise. This E, remember, is times 10 to the 23rd. So I'm going to go ahead and write that down. So my final answer is 4.902 times 10 to the 23rd molecules of water. And that is how you do it.